So this little video is going to be about sketching these rational functions. Okay, so for almost every rational function, we want to first start off by finding the domain, or rather the domain restrictions. So we want to know what number or numbers will make the denominator equal to 0. Okay, and whatever numbers will do this, those are the ones we have to restrict from our domain. Okay, and it turns out that those restrictions either tell you it's going to be a vertical asymptote or it's going to be a hole in your rational graph. Okay, so that's one of the reasons why we find the domain, is because those are your potential vertical asymptotes or holes. Okay, and the way we decide if it's a vertical asymptote is when you plug positive 2 back into your equation. Okay, we get 4 times 2 cubed divided by 2 cubed minus 8, which I believe is 32 divided by 0. Okay, so when we have 32 divided by 0, that tells us that we have a vertical asymptote at this x value. So we have a vertical asymptote at x equals 2. Now, if we come out to have a 0 over 0 as our answer when we plugged it in, that would tell us that we would have a hole. But because we have a number 32 over 0, that is our clue that we have a vertical asymptote there. Okay, if we were going to take the limit of this function as x goes to 2, the answer would be does not exist. Okay, the limit does not exist when we have a vertical asymptote. Okay, so let's skip the next part real quick, the profile. It doesn't have any holes, so we can skip this part also. So we're going to be asked, does this have a horizontal or a slant asymptote? Okay, so to answer this question, we're just going to look at the heaviness. Is it a top heavy, bottom heavy, or a neutrally heavy rational function? Okay, and hopefully you can see, because there is an x cubed in the numerator and there's also an x cubed in the denominator, that this is a neutrally heavy function. So when it's a neutrally heavy function, our answers come from the coefficients. So we have a horizontal asymptote at y equals 4 divided by 1, which is simply enough y equals 4. So we have a vertical asymptote at x equals 2, and right now we have a horizontal asymptote at y equals 4, which we're going to sketch in a minute, but let's just do all of our math to solve for a second. Okay, our y-intercept. Hopefully you love this one as much as I do. To find the y-intercept, you just plug in 0 for all of your x's. Okay, and 4 times 0 cubed is just 0. So 0 over negative 8 is a y-intercept of 0. Okay, so this has an intercept at the origin. So we have a y-intercept at 0, 0. And it turns out always, if we have a y-intercept at 0, 0, that our x-intercept is also going to be at 0, 0. But in this case, when we solve your numerator, and that is always how we find our x-intercepts, is you solve your numerator. So you set your numerator equal to 0. And we find that x has to be 0 also. So it has an x-intercept at 0 and a y-intercept at 0. They both cross at the origin. So we have some pretty good information. So let's go ahead and do a sketch. So I'm going to do my best to draw a nice vertical line, as vertical as it can be. That's pretty okay. And a horizontal line, as horizontal as it can be. And that's pretty okay also. So there's my y-axis, and here's my x-axis. So let's start putting on our attributes. We have a vertical asymptote at positive 2. So you put 2 tick marks over in the right, and then you have your vertically dashed line that represents our vertical asymptote. And you go to your y, and we put 4 tick marks on the y-axis. and you have a horizontally dashed line which represents our horizontal asymptote, y equals 4. And then we have our intercepts, which are both at the origin, so you only have to do it once. We don't have to do anything other than that. Okay, so this gets us a pretty good sketch as what's going on. Now we have this question about the profile. So the profile is what is happening with the x's on the left or the right side of your asymptote. Okay, and that's going to answer our profile question. So what we do is we plug in a number a little bit to the left of our asymptote. So maybe 1.9. Since positive 2 is our asymptote, let's try a number like 1.9, which is just a little bit to the left. So 4 times 1.9 cubed over 1.9 cubed minus 8. And we are just checking for the positivity of this number. If it's a negative number, then our graph goes down on the left of our asymptote. And if it's a positive number, then the graph goes up. So 1.9 cubed, that's a positive number, times 4, that's also a positive number. So our numerator will always be a positive number. And 1.9 cubed, well, that's a number less than 8. Okay, I know that 2 cubed equals 8. So 1.9 cubed must be less than 8. Because 1.9 is less than 2. So if I have a number less than 8 minus the number 8, I'm going to have a negative number as my answer. So a positive divided by a negative will always be a negative. So my graph will go down on the left side of our asymptote. Okay, so I'm going to show that with a down arrow on the left side of the asymptote. Okay, the graph will go down on the left. That's its profile. Okay, now I'm going to do a similar algebraic exercise on the right side and plug in a number of 2.1. So 4 times 2.1 cubed over 2.1 cubed minus 8, and do a similar exercise with numerical analysis. Okay, so 2.1 cubed, that's a positive value. A positive times positive 4 is a positive. 2.1 cubed is a number larger than 8. So a number larger than 8 minus 8 is also a positive number. So a positive over a positive is a positive. So our graph will go up to positive infinity on the right side. Okay, so I'm going to come up here to the top of the page and put an up arrow on the right side of my vertical asymptote. Okay, reminding me about what the profile is doing there. So now that I know the profile around my vertical asymptote, I feel pretty confident that I can sketch this graph pretty well. So if I start on the left side of my axis, I have to come up and go through my origin, right through my x and y intercepts, and then I have to bend out to the left to approach my horizontal asymptote. Okay, so the left quadrant of our graph will look like that, and the right quadrant, upper right, so start at my positive infinity, and then it will curve out to the right and approach my horizontal asymptote, something like that. Okay, so this is a pretty good sketch of 4x cubed over x cubed minus 8.